So now that our programs have numbers, we need to actually do something with them. So just like you've learned in your math classes, we can do some basic calculations, and they'll follow the order of operations. Now, you need to pay careful attention today. Java can be very fussy when it comes to integer values, so keep your eyes open. There are a couple gotchas along the way. So today we're going to start off with some code. Basically, I've got int num1 equals 18, int num2 equals 3, and then we're doing an output statement with a plus sign. Now, this plus sign is different than the ones we've used so far. We're not really gluing the two numbers together. This actually means to do addition. So let's compile it and run it. And you'll notice it's basically acted like a calculator. It's done a calculation. So 18 plus 3 gives us 21. So you can type in all kinds of different basic calculations using plus, minus, multiply, divide. So as we just saw in the code, Java can handle addition by using a plus sign, and it has all the other basic operations built in. Subtraction, multiplication, division. Now these two symbols are different than what we write down on paper, but there's no division symbol on the keyboard, so we just use a slash. They're the same symbols that a graphing calculator uses if you've used one of those before. Now notice right now we don't have an exponent or a square root. Those are actually extra features that we'll have to add in to our program. We'll do that in a couple lessons. As we talked about, Java follows the order of operations. So if I set up int x equals 9 and y equals 2, and then I set up a third box z, the way this is going to work is Java does all the calculation over here on the right side and then takes that answer and is going to assign it to our memory box z. Now, in order of operations, multiplication comes first. So the first thing it does is takes y and multiplies it by itself. So 2 times 2 would give us 4. Then it's going to add on x, which is 9. So 9 plus 4 is 13. And that gets stored in the memory address described by z. So pretty basic. Now let's look back at the code here and look at how Java handles division real quick. So I'm going to take num2, which is equal to 3, and divide it by 2. Now, we expect half of 3 to be 1.5, but let's see what Java actually does. Notice here we get a 1. It's a very odd thing that Java does, but it basically can't store a decimal value in an integer. And since num2 is an integer, that's the space it sets up in active memory to do the calculation. And so, instead of 1.5, it basically cuts off the decimal part and leaves us with just the 1. So as we just saw, Java can treat integers and calculations a little bit oddly. So again, here I have int a equals 5. So when I do a divided by 2, our expected answer is 2.5. But Java does something a little tricky. Active memory is the spot where Java does all its calculations. That's what the CPU uses. So since the very first thing it sees is an A, is Java sets up a little tiny box in active memory that's just big enough to hold an int value. So when I do 5 divided by 2, it can store the 2, the integer part, but the 0.5 basically is not going to fit in our box here. So Java just decides to cut that off for us. So let's look at what we can do to fix that. The trick here is we don't want Java to hit an integer first. So all we have to do is do 1.0 and times. And basically what Java sees first is the 1.0 and says, aha, I'm working with doubles. So it sets up a nice big double box in memory. Then it multiplies that by the 3 here in our example, then divides by 2. So if I recompile and run, now we're getting the 1.5. This is something to be very careful about with your calculations, especially averages and things like that. If I was running a program to calculate your test average, and your test average was, let's say, an 89.9, in theory I should round that up to an A. But Java, if I was using integers, would chop off the 0.9 and leave you with just an 89B. So these kinds of calculations can be a little bit tricky, so you want to test with lots of different kinds of numbers to make sure you're getting the correct result. Now, let's look at another example. I have int a equals 11, double b equals a divided by 2. Now, you would think that because I have a double here, Java would be just fine and we would get 5.5. But again, the way Java does this is it actually starts over here. It does all the calculations first, and then it does the assignment. So the equal sign, actually with order of operations, happens after all the multiplication, division, addition, and subtraction has been taken care of. So since it starts on this side of the equal sign, the very first thing it spots is an A, which again is a little tiny box in memory for an int, and it does 11 divided by 2, plugs in a 5, and then it assigns it over to the double B. So when I print, it'll print out a double value, but it gives me 5.0 instead of 5.5. So again, our fix with that is to add the 1.0 times right here in front of our A, so that the first thing Java hits is a double value. Now I'd like you to try it. Input 2 integers and find the average. Please make sure that your average displays a decimal value.